Hi, I'm Saptanshu Samal, and the topic of our group was mathematical modeling in gas hydrate recovery. So basically, gas hydrates are crystalline structures which are formed as water traps smaller molecules such as methane in their clathrates, which is a cage-like structure, and this is a crystalline solid which is like ice. So the first type of modeling we are doing is thermodynamic modeling of the formation of gas hydrates, and these are the certain variables which will be utilized in a further derivation. We use the Redlich-Kwong equation of state, which is for real gases, to thermodynamically model the formation of gas hydrates. We also use Langmuir adsorption kinetics, upon which we'll discuss ahead. And during equilibrium conditions, the fugacity of the gaseous phase and hydrate phase is equal, and that is what we numerically simulate. We solve all these equations and also use the Lee-Kessler correlation for the fugacity coefficient, and the degree of freedom is 1, which means that we need to specify one of the variables such as temperature or pressure. In our simulation, we specify the temperatures, and pressure is a dependent variable on temperature, so we get such kind of plot. On a theoretical modeling, it seems something like that, and one of the experimental models or empirical models developed by Holder and Kamath, which utilizes the data of equilibrium pressure and temperature to find when will gas hydrate be formed. The region below the line suggests that no hydrate formation will take place. This is a three-phase line, which means there is hydrate, there is methane, and there is liquid water, because it is about 273 degrees centigrade. And no hydrates will be formed below this line, and above this line, hydrate formation region will take place. This plot helps us to predict when, at what combination of pressure and temperature hydrates will be formed, and this is important to develop strategy for gas hydrate extraction, because we can depressurize, that is reduce the pressure to, as you can see that in the lower region, no, in the lower region where the pressure is low, hydrate formation is not taking place, and at the higher temperatures the hydrate formation is not taking place, so we can heat and depressurize, which is a strategy. Then we do a kinetic modeling based on analogy of Langmuir isotherm. We use Langmuir adsorption isotherm to basically find the expression of theta. Theta is basically the fraction of cages occupied by the methane. So as you can see that as pressure increases, the fraction of cages occupied also increases, and we can also see that it is a the constant, Langmuir constant, is a function of temperature, and the reaction and we use this function of temperature to get the fractional coverage as a function of both pressure and temperature. And this also is used for similar extraction strategies, that we can predict when, at what combination of pressure and temperature, and how much fractional coverage will be there, and how much gas hydrates can be formed. Then we also do a source modeling of methane leakage, which we utilize one dimensional diffusion equation, which is given as such, and we simulate it. We use an analytical approach to find the solution of this, and also a numerical method, that is finite differences method, to find the plot. And we get a such kind of plot where we can see that the with increase in time, the concentration of methane around the source decreases, and it starts spreading around one direction, that is x direction. This leakage of methane results, what we can say is that this model will help us to study if there is any leak, and like make strategies how we can contain the leak of methane, which can be harmful for marine life. Then we also model the gas hydrate crystallization, which we can see at what rate crystallization will happen, and we model it based on temperature and pressure, which are function of time, and as they increase or decrease over time, and how hydrate formation rate is affected by it. And the degree of freedom is 0 for this, and we numerically solve this to get the temperature over time and pressure over time and gas concentration and hydrate formation rate. And thank you. Stop कैसे करते हैं?